So we need to make sure that we really focus on the proofs, because just identifying what theorems needs to be used is pretty easy. The hard part of this section would be the theorems. So the best way to introduce these theorems is by using side, 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 because it's a pretty easy theorem to prove, because you're just getting 3 sets of congruent sides. All right, so we need to remember our reflexive property, our symmetric property, and our transitive property. Well, your reflexive property is when something is congruent to something, right? So whether it is an angle, so like angle A is congruent to angle A, or it can be a side, such as line segment AB is congruent to line segment AB. Reflexive property. Now remember, in naming line segments, does order matter?
Yes.
Is line segment AB the same as line segment BA?
No. Yeah.
It is. Arrays order does matter. Arrays would not be the same. But line segments, the order doesn't matter. And there will be some times where we will have line segment AB congruent to line segment BA, and that's still okay because it's the same line segment. Okay, symmetric property. Remember, if we had something like if angle A is congruent to angle B, then your reflexive property just tells us we can flip the order. So angle B is congruent to angle A. We will not be using that at all. We used that back when we were solving for X. If you guys remember doing that back in chapter 2. And then transitive property, we had something like if angle A is congruent to angle B, and angle B is congruent to angle C, then what's true? A is congruent to C. Remember, we take out the middleman of B. So if they're both congruent to B, we can eliminate that. So for chapter 4, put a big star next to reflexive property. That's going to be your best friend. Transitive property was our best friend in chapter 3 when we were proving lines parallel. But in chapter 4, we're going to be loving the reflexive property. Okay? All right, so let's go ahead and work through an actual proof. So we have triangles shown up here in our diagram. We have our given. If I don't have the given in there, you are more than welcome to be lazy and just write given and really large on the top. Did I put it in there for you guys? I did not. No. Okay, so rules of thumbs when doing proofs on triangles. Mark up the diagram with whatever is given to you. In this case, they did already mark it up for us. So what did they give us? They gave us one set of sides congruent to each other. So side HF, which is already shown here with a single tick mark, is congruent to side HJ. That should not be J, that should be an I. Let's turn that I into a J up there. Turn that I into a J so we're consistent. Okay, so HJ is congruent to HF. So what I would like you to do is right above where I have it highlighted purple, can you put an S for side? So there's one set of congruent sides. Then what's next in the given? So I'm going to highlight it in green. Do I have another set of congruent sides? I do. FG is congruent to JK. So I'm going to put a little S there. So in order to prove something with side, 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 I need 3 sets of congruent sides. How many were given to me in the given? 2. So that means I only need how many more? 1. All right. So now to get that 1, I'm going to go back to what we know about doing proofs and look for key vocabulary in the given. What key vocabulary do you see? I see the word midpoint. So that's my line 2. Line 2. If midpoint. All right, think back. What do we get with a midpoint? 2, we don't want equal, we want 2 congruent segments because I need them just to be congruent to each other. We're going to stay in congruent world and not go to equal world in any of these proofs. So if midpoint 2 congruent segments, oops, I forgot my then, that's okay. Which means over on the left-hand side, what do I need to show? My conclusion, which is 2 congruent segments. So that means over here, I'm going to have some type of segment congruent to some type of segment? Well, midpoint is H is the midpoint of GK, so where are your two congruent segments?
H and HK.
Perfect.
K is congruent to HK.
So either way would work. I went GH, but if you went HG, now here order, you have to really make sure you pay attention. If I go GH, then my other side should technically be KH to keep those corresponding parts matching up. Okay, so now do you have 3 sets of congruent sides? So now I'm done. So now what was I trying to prove? I was trying to prove that triangle FGH was congruent to triangle GKH. So let's rewrite that in line 3. Oops, FGH is congruent to triangle JKH. And then the beauty of this is, I'm just going to say, because of side, side, side congruence. If I am claiming that I have side, side, side congruence, then I need to make sure I have 3 sets of congruent sides. I have one here in line 2, and I had the other 2 already given to me, so that was nice. Okay? That's a triangle congruence proof. I proved that triangles are congruent to each other. Questions with that? So these won't be like really long 8-liners like we have done in the past. Okay, proof number 2. Yeah, that's all we gotta do. Get 3 sets of sides. All right, proof number 2. Guess I don't have this set up for you guys. Sorry about that. So we got statements on the left, reasons on the right. Line 1 is always your given. All right, so let's look at our given. What's given to me first? Oh, well, congruence. Perfect. What's congruent? GH, single tick mark, JK, single tick mark. So there's a set of congruent sides. I'm going to put a little S up there. What else do they give me? Well, they give me HJ, double tick mark, is congruent to KG, double tick mark. So there's a second set of congruent sides. Which means I only need how many more sets of congruent sides? 1. Where is it? In the middle. Straight down the middle. Because of which property? Reflexive tells us that something is congruent to itself. So, line 2. I'm going to put a reflexive property in here. Which means I'm going to say over here, my side that is congruent to itself. Now we will have to pay attention to order. I will not be picky about it on the quiz or the test or the quest, whatever we want to call it. So if you go JG, technically, because there's see how this triangle would be rotated? So if I rotated this bottom triangle to overlap to the top, J would overlap with G, and then G would overlap with J. Or you should see it up here in the congruence statement, right? It would be J, or GJ would match up with JG. So technically, you should switch the order. If you don't, and you just put JG is congruent to JG, I would give it to you, as long as you have your reflexive property in there. Now do you have 3 sets of congruent sides? Yes. So I'm done. So now I can say that my triangles are congruent because of side, side, side congruence, which means over here I'm going to state which triangles are congruent, which is just my prove line. So GHJ is congruent to triangle JKG. Now, what do you notice about the given in the first proof and the given in the second proof? They both had 2 sets of congruent segments.
This one uses the reflexive property.
Right. Why do you think we use the reflexive property? What was missing from the given that was there in the first proof? There was a key vocabulary word in the first one, wasn't there? In this one, there was no key vocabulary. So put a little star next to this one and put, if no key vocab or symbol, then look for reflexive property. And a reflexive property is just when they share that common side. So there'll be some type of diagonal through a rectangle or a parallelogram, or it'll be a triangle on top of a triangle, so it'll kind of look like a diamond with the line going straight through it. So if you've got no key vocabulary, look for the reflexive property. That does not go to mean that you could have key vocabulary and a reflexive property happening at the same time, too. That may happen. But if you have nothing, then result to reflexive property. All right, example 3. Would this be a reflexive property? Do we have a side and a side in common? We do not. Okay, so I don't have a reflexive property here. So let's go ahead and set up our T-chart. We'll be lazy. SR, left, right. Line 1 given. Okay, in my given, how many sets of congruent sides do I have? I only have one set, right? So that means I need to come up with how many more? 2. Perfect. Okay, so now I don't have a reflexive property because I don't have any sides shared. So now I got to look at my key vocabulary, which is midpoint. Notice it says that B is the midpoint of AE, which is this whole side. So let's start there. So if B is the middle of AE, where are my congruent sides?
AB and then.
Perfect. Okay, so AB and EB is what we want for line 2. So line 2, if midpoint, then 2 congruent sides. And then what are my 2 congruent sides? AB, EB, we said. Again, you really should try to have your corresponding parts matching, but I won't be a stickler on it. So if you just say A, B, and B, E, I would give it to you. But just be aware that you should have it matching up from your corresponding parts. Okay, so now we know B is also the midpoint of CD, so that's going to get your other part. So CB and DB. CB is congruent to DB. And then I can just ditto mark that. Or rewrite it if you want to rewrite it. And then we were given AC and ED. So now do you have 3 sets of congruent sides? Yep, you had 1 here. That was 1 set. Here we just put a second set. Here we just put a third set. So now do I have 3 sides?
Yes.
So now my triangles are congruent. So now I can rewrite the prove line. So triangle ACB is congruent to triangle EDB because of side, side, side. Oops, missed an S. Congruence. Questions? All right.